Welcome to the Unity Engine roadmap, where we're at and where we're going to be going. I'm Andrew, I'm a Senior Director of Product Management here at Unity, and
I'm Will, a Principal Designer from the Product Design team.
So before we get started, here is our safe harbor statement. This presentation, of course, contains our future plans, so please don't make any purchasing decisions, because those plans can change at any time. Today, we're going to cover two big areas. We're going to talk about what's next for Unity 6, and what comes after that, or the next generation, if you will. So sit back, relax, and enjoy the next 45 minutes with us. Take it away, Will.
Thank you very much, Andrew. So kicking off with Unity 6, building the best version of Unity. If you just came from the keynote, you'll know that Unity 6 allows you to create more optimal games on more platforms. Unity 6 comes with faster rendering from GPU Resident Draw. There's lots of neat quality of life enhancements for productivity across the board, like this asset bundle defaults option. We have deeper support for mobile web runtimes. This is super impactful if you're working on mobile and have people play your games in the browser. And there are expanded AI capabilities with Muse and Sentis. Here in our Time Ghost demo, we used Sentis to enable realistic cloth deformation at runtime with a machine learning model that we trained ourselves. And with Muse, we're enhancing workflows through deeper AI integration into the editor. Two examples, so this context-aware chat that understands the context and the content of your project and can even carry out instructions for you. So here we're asking it to add gravity to this boulder, and of course it adds a rigid body. So a very simple example, but there's lots more to come. And there's 2D enhancers, like this sprite upscaler that you can up-res your sprites basically right inside the sprite importer. Super helpful. And there's powerful lighting with adaptive probe volumes. And of course, end-to-end multiplayer workflows. So what do we mean by that? Well, the amount of work we've been doing on multiplayer in Unity 6 is absolutely huge. We want you to get started with a prototype in lightning speed without leaving the editor. So multiplayer play mode and our services integrations really take care of that. You can target anything from simple, cost-efficient, client-hosted games all the way up to your high-performance server-hosted titles. And we're giving you everything that you need to keep your players engaged and to grow your own community. So there's a lot more to come in the Unity 6 generation. We're going to talk about that shortly. Speaking of generations, back to you, Andrew, to talk about how we release.
So we're moving to a new generational release model. So what is that, and how does it differ from what we do today? So a generation corresponds to a major version of Unity, so think Unity 6 and so on, and it will run in many ways like the LTS does today, but with a few focused improvements. First, the time between generations, those major versions, will be longer, generally a minimum of 2 years. So that's longer than you were used to with an LTS. And that's going to provide you with those longer periods of stability. Then we'll provide fast, frequent patch releases, just like the LTS, and then something new, update releases. So these are like a patch, but with an additional period of stability or stabilization before they release. So this improves over the LTS, especially where we want to ship larger things, new platforms. So rather than these arrive in a patch, they'll be part of a stabilized update release. Through all of this, we're optimizing for minimal upgrade disruption. And finally, this model enables us to work on the next generation of Unity in parallel. And those new generations are going to enable us to deliver big impact so that we can keep the engine evolving. We want to provide stability with the current generation, what you have today, and then a next generation that stays ahead of the ever-advancing needs of the industry. So let's take a quick look at what this means for Unity 6. So firstly, in the run-up to a new generational release, we're going to go through alpha, beta, and preview. I think you saw that already with Unity 6, which is now in preview, and about to move to full release on, what was that, Will? October 17? Yeah, that's pretty cool. So once we fully release, it's going to operate much like an LTS. So that means a minimum of 2 years of support with an additional year for enterprise customers. And we'll always ensure an overlap between the current generation and the next. And we'll be extending the support window once the plans and the specific dates and timing around the next generation become clear. So with this long dev cycle, and this is the key part, it really gives us more time to evolve Unity and adapt based on what we hear from you and your feedback. Quick note on patch releases. So these, as I mentioned, work just like they do with the LTS for Unity 6. We're going to ship patches every 1 to 4 weeks. The time frame is going to expand the longer the generation has been out. Patches are focused on bug and security fixes, and it's also how we can respond quickly to sudden platform, legal, security, or regulatory changes, the things we really love, right? Now, back to update releases. These are the new things. So as you'll remember, with the old LTS model, we would have to sometimes land these big things in patches, like new platform support. The new generational model, we want to improve. So an update release works just like a patch, but with this additional stabilization period. And to ensure stability and ease of upgrade, we have really tight constraints at what gets to go into an update release. And one important note here is that an update release does not constitute a new generation. The support window starts when the first generational release ships, and it doesn't get reset with an update patch. As issues get fixed, they get released in patches and rolled up into an update release. We do pack port between generations, but not within them. The first update release will be 6.1, as you heard earlier, and it will enter beta in January and ship in April of next year. The cycle then repeats itself through the generation, and we'll be documenting a lot more about this in our blog, so watch out for that. That was quite a lot about how we release. Shall we get back to what's
That's
actually
my favorite part of the roadmap, Andrew, isn't it?
Well, I promise it's going to get better from here, Will. So let's talk about what's coming next to the Unity 6 generation. The focus of this first update release, and in fact all update releases for Unity 6, is going to be about quality, performance, platform updates, as well as additive features, things that you can opt into, feature enhancements, and so on. Essentially, the update releases are just ways we can keep the bar high for the generation and just keep moving it up. So let's take a quick look at what we have in store. First up is graphics. So MeshLOD, it's our new lightweight LOD system that's complementary to LOD groups. Our goal is to have as simple as a possible solution to automatically generate LODs at import time and automatically select the correct LOD based on distance at runtime. Let's take a quick look at this in action. So here, we're seeing our tavern scene. It contains lots of props and lots of characters. And to generate the LODs in these 45 assets, we're just going to select them here in the inspector here and basically enable MeshLOD in the importer. And MeshLOD places the LODs in the meshes. You can then preview those on each mesh individually if you wish. MeshLOD works on static meshes as well as on skin meshes. Each LOD, of course, trying to keep the best visual quality possible while reducing the number of triangles. With a scene like this, MeshLOD allows us to go from 81 million tries down to 4.5 million without downgrading visual quality.
Pretty good.
Really smart stuff. Right, moving on to optimizations to our deferred rendering path, which is called Deferred Plus. This is also bringing a number of really useful benefits. So for scenes with complex lighting, it brings 2 immediate benefits. Firstly, it uses advanced cluster-based light culling. That really accelerates your overall GPU performance. And secondly, Deferred Plus with GPU resident drawer now accelerates the URP render loop by, of course, efficiently batching those draw calls across multiple threads. And then, specifically for mobile, on-tile deferred rendering brings improvements to mobile devices. Now, URP is optimized to utilize the latest tile-based rendering techniques, so that's native render pass and frame buffer fetch, to reduce bandwidth usage and energy consumption. As you can see here on the left, the deferred passes are merged at the top and using the frame buffer fetch, which are entirely done on tile. So in turn, mobile devices can run longer and maintain higher frame rates. So with that, let's keep going with platforms, and back to you, Will.
Thank you, Andrew. I'm glad we can finally make frame buffer fetch happen. Next up is platforms. In Unity 6, we added build profiles and the platform browser. And together, these windows provided a whole new workflow for those of you targeting multiple platforms. Coming in the 6th generation, new profiles will have pre-configured settings, recommended packages, and even sub-profiles. So when we know that you're working with a particular platform, we can deliver a great set of default profiles and settings all in a single click. Finally, we're adding these really useful override options, like, for example, global graphics settings. This means you can set per profile quality levels as well. Really useful. This is another big one. We're improving support for large screens and foldables. We'll leverage the latest windowing Android APIs, and you'll be able to react to real-time configuration changes from C#. So for things like orientation, screen layout, resolution, as well as the hinge presence and the angle of the hinge as well. For XR, we're making it easier than ever to work more efficiently with improved scene setup by introducing a series of common XR functionality that you can easily add and then customize during production. We think this is going to save you significant time and effort working in XR projects. For mixed reality, we'll be sharing a new tabletop game example that demonstrates how to build multiplayer experiences in mixed reality. This template is going to incorporate really the best of our XR support and our multiplayer support. Lastly, on platforms, we know that sometimes building for XR devices can sometimes be a complex process. There are many settings in many different places that have to be configured in order to successfully build for things like MetaQuest. So to solve this, we're adding a dedicated build profile for MetaQuest, making it significantly easier and faster to configure your projects. So moving to the web now. As you saw in our keynote, you may have done, Stratton Studio's Project Prismatic is really representing the next generation of web graphics. Our web GPU graphics backend is taking strides towards being production ready, and we're now confident enough to make it available in the project settings so that you can easily try out the state of the art in web graphics. Continuing with the web, in our next 6 update, we're pleased to announce the full release of instant games for Facebook and Messenger. That means that there's a new build target, which is going to streamline building, optimizing, and even uploading instant games to Facebook and Messenger. With our WebAssembly stripping tools, you can strip out parts of the assembly that aren't used in your game via runtime analysis. And finally, the C# Instant Game SDK has bindings for Meta's Instant Game API endpoints. So when you're ready to test, you can basically upload your instant game directly from the editor to Meta's dev backend, which is going to save you a ton of time. And just to show off some optimizations that we're making for instant games, have a look at some of these numbers. So using that WebAssembly code stripping that I mentioned, along with editor settings, you can really dramatically reduce the load and startup times of your web games. So here are the results of that tool today, but we're already finding lots more ways to make optimizations and improvements. And already this is a game changer for instant games. You can see here that anything from 14 to 82% reduction in load time. So that's an average of 56% reduction across all of our tests so far. Pretty awesome. Next up is multiplayer. And as we've said, this is a big, big focus for Unity. We know that many of you want to make multiplayer games. Many of you want to make mobile games. And of course, you want to make multiplayer mobile games. So we're bringing multiplayer play mode to mobile. You'll see this first on Android platforms. To help you get started quickly with multiplayer dev, we've been sharing these UI preset widgets for some time that include hooks into our multiplayer services. This allows you to very quickly prototype and connect to the service and try things out. We're soon going to add a matchmaking service to this as well, so you can easily drop these into a project and try that out. 2 more big challenges that we're solving for multiplayer. So first, what happens in your game when the host drops out? And second, how do you scale and maintain performance? So we're adding host migration support to netcode for entities, and this is integrated with our lobby multiplayer service to ensure that the gameplay continues even if the current host drops out by allowing another client to just take over. Super useful. And not only this, but we're also improving performance of our distributed authority, easy for some to say, distributed authority model in netcode for game objects to ensure a seamless experience for all players. We also want to make sure that you can really focus on multiplayer development in the editor, hence the widgets and the service integration and so on. And for simplicity, we're also exposing session management through components and scriptable objects inside the editor. This is going to give you everything you need to manage the game state, so aspects like creation, joining, session data, controlling membership. And you can customize the session with the modular interface that we're going to expose as well. Last but not least for multiplayer, we remain dedicated to support you with your in-game communication and moderation with the power of AI. With Positive Play, we intend to help you identify and reward players that are actively making your game better so that it can have an even greater outsized impact. And when it comes to taking action, we're also developing new solutions to automate reporting and moderation actions directly based on what the players are doing, so saving you a lot of time and making your games overall more positive. And of course, it's not all about games. We're also seeing a lot of adoption in commercial embedded systems for industries like automotive entertainment, public signage, consumer devices, and things like this. With Unity 6 Industry, we support embedded Linux, Android, and QNX, and we'll provide pre-validated configurations on various chipsets, as well as support for custom integrations as well. New platform features that we have include multi-display improvements, improved lifecycle management, and support for QNX 8. And we're continuing to support our Unity as a library for various different use cases that you might need it. So Andrew, I think you'll agree there's absolutely tons of stuff coming to the Unity 6 generation. And this is just what we could fit into this talk, of course. There's lots more coming as well.
Yeah, look, it's a really great example of how committed we are to the Unity 6 generation, which is a generation that will be supported for many years to come. So let's recap. Unity 6, it's in preview now. Go grab it. Unity 6 general availability is coming October 17th. And we talked about our new generational release model and how this is going to bring improvements to quality, security, and performance to Unity 6 in a very stabilized way, and then how we bring platform updates and additive features through our update releases, with the first update release coming in April of next year. So, Mr. Goldstone, how are you with your future casting?
Well, they call me the Nostradamus of Unity, Andrew, but let's pretend for this that I can't do that.
Yeah, I think, that's true, because I think no one really among us can predict the future.
That's not true.
But, we do know that there are certain trends and certain trajectories that are here to stay. So we know that games are growing. We know that many games are becoming platforms with these huge player bases and annualized content. And smaller games are growing in terms of the number and breadth of their gameplay and storytelling. So to keep up, we're looking ahead at all manner of trends in gaming. And we're working on a number of projects to future-proof Unity, not just for the games market of today, but for the market that we see coming in 5 years and beyond. So what we'll show you today is a small window into some of the work that we've been undertaking in the last 2 to 3 years to really prepare the next generation of Unity for the future.
Yeah, we should take a moment to kind of emphasize that this is not what we've done with roadmaps in the past. This is a kind of new way to deliver the roadmap. And we want to be more open about the future, what we're working on, in a way that creates a better feedback loop with all of you, so that we don't drop a big major release and you get surprised and say, what's all this stuff? We really want you to be a part of developing that. So that's why when you might see, oh, Unity are disclosing things a bit earlier, that's what we're doing.
Speaking of which, we've heard a lot from you over the years that you've wanted performance, quality, stability. And that's absolutely our goal with the Unity 6 generation. But we also know that there are aspects of Unity that are going to require re-architecture, really in order to fully address the needs you have. And that's why we're developing our next generation in parallel with Unity 6. Our goal is to ensure you have this future-proof engine that not only meets the needs of the ambitions you have of modern game development, but it also rectifies a lot of that complexity that's made it harder to use and extend from the Unity platform. So let me tell you how we think about this. What are the big themes? So first, simplicity. We want to make the default choice in Unity the best choice. And in the past, you've had these multiple solutions. We want to unify and bring that down to just one. Iteration time. We are waging war on iteration time and progress bars. We want to improve iteration times across the editor and engine. Fundamentally, we want to bring productivity back to an all-time high. And lastly, power. Well, it's just about bringing you the best possible tooling, the best possible runtime performance that just means you can scale to meet your ambition. So Will's going to take us through the first of these, simplicity.
Absolutely. Thank you, Andrew. So like Andrew said, this is about reducing complexity and building better default solutions. And today, we'll talk about how we have single solutions for things, how we aim to get feedback on that, and then talk about how we're simplifying rendering. So simplicity is the opposite of complexity, and as we've built more and more functionality over the years, as you all very well know, we've not taken enough time to make sure that that functionality that we added is easy to use and intuitive to access. So we want to get to a place where we're offering you, one great way to set up input, UI, etc., one great way to author a scene, one great way to build. And we know that this likely means you're wondering, what does that mean for features in the editor? Well, basically, it means that we're taking a new approach to deprecation. We'll mark a feature as planned for deprecation within a generation, and based on your feedback on the replacement functionality, deprecate it in the following generation. We think that this is the best way to move Unity forward architecturally and allow us to deliver you the best set of default options. Our first example of this is UI Toolkit, in which we're focused on key areas which we think will make it be the best solution for UI. So we're talking about world space UI, custom shaders, full animation keyframing, multi-language support. Yes, we mean right-to-left text, and of course, emoji too. And of course, we mean superior performance as well. So we take this very seriously. And this list, on top of what UI Toolkit can already do, is an example of how we'll work with you to validate that this feature is actually ready to be that singular solution. Whilst, of course, we continue to support Unity UI, aka UGUI, throughout that next generation. So it's not a scary kind of cutoff. We really want to take this seriously and work with you to say, is this the right time to deprecate any given feature? This is an example. Another great example of this simplicity work we can share is in graphics. As many of you know, we've been working on the scriptable render pipelines for a few years, creating a set of functionality that spans all quality levels, styles, genres, and platforms. We've seen some amazing titles made using SRP. In the past year, 90% of games on Steam made with Unity were with SRP, and more than 50% of mobile and XR games were made with SRP. As you'll also be keenly aware, your choice of render pipeline is something that you need to choose up front today. URP is still the best choice for mobile, XR, and cross-platform, with HDRP for high-definition stuff across PC and console. But you know what? One of Unity's core tenets was always to help you author once and deploy anywhere. So making you choose and compromise is the opposite of that. So yeah, choices are hard. What if we could remove that decision? Well, spoilers, that's exactly what we're going to do. In our next generation, we are unifying rendering. Yep. Pause for applause. Oh, that's the stage direction, sorry. First things first, before we get too excited, we'll be removing the former built-in renderer in our next generation. This is a roller coaster, isn't it? We'll be marking built-in as deprecated during the Unity 6 generation, but it will continue to be supported throughout that generation, for years to come. We know that this is going to have a large impact on many of you. Our recommendation is to migrate your work or familiarize yourself with SRP in your 6th generation projects. So plenty of time to do that. And you can also check out Mathieu is doing a talk on migrating to URP at the Unite event today, or if you're watching this on the stream, check it out on our YouTube channel. So in our next generation, we're going to move to a scalable, unified rendering strategy that will help you take full advantage of the hardware that your game runs on. Unified rendering means that we are not creating yet another solution, but refactoring the URP and HDRP backends to allow us to separate data and logic and give you a completely unified authoring experience. So lights, cameras, materials, and effects will be authored once. That's your data. Then we'll enable you to configure the rendering logic to scale across all of the platforms of your choice. And when unifying, we're really taking the best of the things that we made for URP and HDRP and making them available to you in a unified way. You'll be able to, so for example, you'll be able to author with either physical light units like you do in HDRP or luminance values like you do in URP. You'll be able to customize rendering with the render graph just like you do in URP today. So really, we're cherry-picking the best tooling that we've made for these render pipelines the last few years. And that means if you're already used to some of the conventions of SRP, you'll be prepared for that next generation. And when unifying, we're also standardizing. The new unified lit shader is based on the Open PBR standard hosted by the Academy Software Foundation. This means you can author in a standardized way between Unity and your art package of choice. That means that, again, with one set of content, you'll be able to scale across all possible hardware configurations, everything from the low-end device with simplified lighting all the way up to the most capable device with the highest fidelity. And because iteration time is important, we plan to make testing multiple render configurations as simple as switching between them in a drop-down menu in the editor. In this early video, we're showing multiple different render loops being toggled by the artist as they debugged how the lighting is going to look across their entire hardware range. The render graph here is just showing you those different passes that each loop is executing so that you know it's real. OK, that's not all for graphics. Obviously, you want a bit more graphics, right? To continue simplifying the experience around art in Unity, we're working on Shader Graph 2 and block shaders in order to solve a couple of specific challenges. First, authoring shaders in code and in shader graph was inherently different. And shader authoring that we had wasn't really portable enough to meet the aspirations of our unified rendering goal. In our next generation, we're introducing a new generation of node-based tools for technical artists, and of course, enabling those of you, many of you are here in the audience, who like to code their shaders as well. Shader Graph 2 is a complete rebuild of our node-based shader editor. It's built on top of our new Graph API. It includes over 20 new nodes, expanded functionality in more than 50 existing nodes, and the ability to create your own nodes using block shader code. There's major UI improvements like these wire portals that you're seeing here. There's better grid snapping, updated node groups, and a more powerful node searcher as well. So you've got things like these groups, which you'll have seen before. And then if you check out the node searcher, you'll see that there's lots of examples built into it, which is really, really cool. Here you can see a wet weather shader, and you can just drop those nodes in. Super cool. Shader Graph 2 shares a common representation of shaders to our new block shader format. You can author blocks that are used from within the graph or from within a surface shader. So whether you're writing shaders for Shader Graph 2 or in code, you'll have the exact same outcome and performance. It's really important. And we think that this creates a common understanding of shaders for programmers and for artists, and we really think you're going to love it. OK, so let's recap simplicity. We have a single unified renderer. Yay. This means authoring assets once for complete cross-platform reach. We're unifying shading with OpenPBR parameterization, meaning you'll be working with an industry standard. And we're making shader authoring far better, whether you're an artist using nodes or a coder using codes. That's the thing that people say. So that's a wrap on simplicity. But of course, you're going to hear more about this theme and the other two themes as time goes on. Andrew, back to you. What on earth are we going to do about iteration time?
Something about progress bars, I think.
Something about progress bars.
Rid of them entirely, hopefully. So, right, what is it? This is all about building a faster and more productive experience, keeping you as much as possible in that state of creative flow. So we hear consistently from you that iteration time is a huge thing to solve in Unity. And we've identified many areas and metrics where we can improve this for you. For example, things like loading a project and entering play mode, importing assets, updating code, editing prefabs, switching platforms, just building. There are lots of little weights that just add up all over the day. So to achieve this, we're going to be re-architecting key parts of Unity in a way that we have not done before. And that's essential to really solve those needs that you have and set you up for success for years to come. So today, we're going to talk about two main areas of re-architecture, our scripting backend and our content pipeline. So as you know, our team has been hard at work on bringing the latest .NET technology to Unity. So when you're working on your game code, of course, we want you to spend time iterating and not time waiting for your code to load. So we're introducing several improvements in scripting to maximize that productivity. First, with the move to Core CLR, we're replacing the former Mono .NET solution with Core CLR. Core CLR is, of course, Microsoft's latest and greatest VM for C#, meaning that you can be always at the cutting edge of performance. And with this Core CLR work, it means that we can stay and always adopt the latest versions of .NET as Microsoft releases them, as is indicated here. And we're going to see out of the box two major benefits there. First, just improved performance of the editor full stop, and of course, improvement of your code, performance of your code at runtime. And we're already seeing inside, certainly internally, a lot of really great improvements for editor responsiveness overall since we've made these changes. But there's also good news for iteration time too, so let's come back to that. So one big change with Core CLR that directly impacts iteration time is the move away from domain reload to assembly load contexts, or ALCs. Today, with domain reload, as you know, all assemblies are reloaded every time. And you can see, of course, that's just a one-to-one. Assembly load context is a flexible way to manage loading and resolving assemblies at runtime. And you have custom ALCs then that basically enable us to dynamically load and unload specific assemblies. So here, quick visual of what that means. So only code that changes is reloaded instead, of course, the whole domain. And that's what brings you back that rapid iteration. And here, of course, you see Unity's core libraries. They don't really change much at all, so they're not part of that. Your studio-specific libraries would be in this long-living ALC, which also rarely changes. And your gameplay code, of course, then sits in the user code ALC. And that's the only thing that gets reloaded, saving a whole lot of time. And if, like Will, you can prepare already for this change by using this Enter Play Mode option. Have you been using this, Will?
I have.
Good. So top marks, Will, and top
Thanks
marks,
very much.
all of you have had this selected. We've had this in the engine for a little while to prepare for this change. Right. So another big win for us is this move away from, or the introduction of the .NET 8 base class library. So this brings new capabilities like hardware intrinsics and math generics that basically just enables you to write that much more efficient and performant code. This is just an example of an integer search function that someone had done exactly that. And then, of course, for easier memory management and smoother gameplay, we're going to be introducing Core CLR's new high-performance garbage collection. And lastly, we're going to be integrating MS Build. So that's the industry standard build system, and it really brings better IDE integration. And with it, a lot of improvements to debugging between native and managed code. So in this video, you can see how this person's basically going to start jumping between C# and C++ in the same session. They attach the process, and in a moment, they're going to start to hop between those methods in their call stack. I mean, this is just a huge improvement in productivity right here, really just letting you really quickly troubleshoot and fix bugs. It's all about keeping you in that state of flow, keeping interruptions to a minimum. So with that, let's talk about another big change we're making, this time to our content pipeline. So just as important as for reducing iteration is how we work with your content. So Unity's content pipeline, that's what manages basically the life cycle of content from import all the way through to the point it is loaded in your game on device. And today, we're going to share one of the changes we're making to Unity's content pipeline, how and when content is imported. So our goal, as mentioned, is to always keep you in that continuous state of flow. Instead of being interrupted, we want you to iterate more and just focus on making the best possible game. And we'll do this in 3 ways. So by importing less, by importing faster, and importing without blocking the editor. So here's the context. Importing and re-importing content is something that happens throughout your workflow for various reasons in Unity today. So in addition to adding new models and textures and audio files and so on to your project, importing happens in a number of different scenarios. These are the same ones I mentioned earlier. And many of these imports are the things that result in those blocking progress bars, which causes interruptions to your workflow. Another way, as your project, for example, grows in size and structure, importing also affects you in other ways here. For example, like this nested prefab as you're editing. So if you're editing, say, this little leaf here in this large nested tree, which is in turn part of your scene, when you hit save, you have to wait, right? And the reason why this gets slow is because every time a prefab is saved, all the assets that contain this particular prefab must be re-imported. And to do that re-importing, Unity needs to load all those objects back into memory, save them back to disk, and so on. So to tackle this, we're making it so that only the necessary content needs to be re-imported. And to support that, we're introducing a new schema-based data model, which is far more performant and just brings you that much smoother experience. And it's a good example of one of those underlying architectural changes that we talked about earlier. Another good example of how we're removing blocking operations. So with the work we're doing in this next generation version, the importer will prioritize the content you open and use background importing for the rest. So this just enables you to get to work far more quickly. So as you can imagine, this means loading meshes, materials, shaders, textures, and so on progressively. It's about giving you that control as soon as possible. It means far fewer blocking progress bars and interruptions to your flow. And if you just think about the time it usually takes you to be productive in the editor after you get the latest changes, with this background import process, that time is really going to be reduced to a fraction of what it is today. It's big stuff. So let's recap iteration then. So our goal is about bringing you a faster editor iteration speed. Our move to Core CLR brings iteration speed and editor performance, and we shared just some of the changes here that we're making to our content pipeline to keep you in that flow, move things to the background. Whew, that's a lot of pretty powerful stuff there, Will.
Yep.
Maybe would you like to take us on with
Got no
something
feelings
about power?
OK, sure. So speaking of which, like Andrew said, we call this next theme power because it looks dramatic on a slide. That's the main reason. But also because it's something that we actually believe in. So let's get on with it. So what we're sharing with you today is a major milestone in our work on DOTS, our data-oriented technology stack. You'll learn how a key part of that stack, Entity Component System, or ECS, is going to give you power to your daily game object workflow, as well as 2 advanced new features. We call this ECS for all. The key part of DOTS that enabled you to unlock and deliver ambitious projects was, of course, ECS in combination with things like the job system and the burst compiler. It's the tech that brought you amazing scale, like you saw in these demos, so everything from our own demos to things like Spell Souls from Nordeus, Mega City, and then, of course, amazing games like Hostile Mars from Big Root Games, with its epic amount of enemies, and, of course, who could forget V-Rising from Stunlock Studios as well, with its hundreds of thousands of interactable objects. Super, super cool. So while ECS is incredibly advanced, many users have yet to take full advantage of it. And we want to bring this capability to a wider audience. In other words, all of you. So that's why we're building ECS into the core of Unity, such that every game object is backed by an entity. That means that everything you need is in the core of Unity with far fewer steps to adopt the power of ECS. Writing game code using the ECS paradigm will be as simple as writing systems and components and adding them to your game objects. As a reminder of why this is so important, just keep in mind that game object data today is kind of scattered around individual allocations throughout memory. And so you're inefficiently traversing lots of different addresses. With ECS, your memory allocations are always laid out side by side in a kind of neat way in memory. And so it's way more efficient to use because of that. And another part of ECS that we're evolving is with the transform. So this is a common bottleneck for the performance of even ECS that we find today. This is because we spend a lot of time reading, writing, synchronizing between the transform representation of a game object and of an entity. And that can really eat into the performance. So this is no longer going to be so with unified transform. Unified transform is going to consolidate the ECS and game object transforms, so we no longer have to do that copying of data between the 2 representations. Another benefit this is going to give us is that we can now have mixed hierarchies that contain both game objects and entities, something that was impossible to do before. We'll now be able to have game object parents with entity children and vice versa. Parents, you should never refer to your children as entities. Anyway, and what segment on ECS would be complete without a demo flex on scale? So here's our most recent Galaxy demo, in which we're showing between 120 and 500,000 entities, all running at a minimum of 30 FPS. And what's more exciting is that we're developing a whole host of features on top of this ECS for all foundation. And this is going to allow you to reap significant benefits even if you don't use the ECS paradigm directly. In fact, 2 of those features are a new animation system and a new world-building system. So let's not just stare into space. Let's take a look at them. So let's start with the new animation system. Whatever your team size, Unity's new animation system will easily take on the most outrageous animation challenges for many years to come. It's designed for gameplay programmers and technical animators to build flexible and scalable pipelines. Let's have a look at some highlights. We'll start with a really big change. You'll see that everywhere in the new system, in just one click, you can preview everything without having to load it into the scene first. Pretty important. This is going to reduce a lot of frustration and human error, as it only will show you the compatible clips with the character you have selected. Our new skeleton workflow allows you to go beyond what's in your imported rig. You'll simply be able to add, edit, and reset your required or default pose, or if you prefer, simply disable bones that you don't need. And all of the changes that we have there, they're stored locally. So making any updates from the art package is way less fragile and far less painful than before. There's a new socket object as well, which is used as a kind of a virtual transform. And this means that it no longer has to be a fragile bone that you create inside your art package, which could get nudged and so on. So here you can see that we're previewing attachments along with their animations. The great thing is that you can edit and preview the socket, and then you can make sure that the position and the orientation of everything is exactly correct for all the animations you're going to apply to it. And this is going to reduce error for, obviously, things like weapon placement that we're showing here. There'll no longer be a commitment up front when importing, as you'll be able to preview everything, edit your clip, and add custom properties. You'll be able to create and edit animation events, and even use multiple tracks, and use range markup as well. The all-new remapping system means that anything is possible. So here are two characters that are going to use the same animation. So you're going to be able to remap anything to anything, independent of naming, the hierarchy, or, of course, in this example, the proportions. And it will work offline and at runtime. So you can see as we apply here, that animation is just working for both characters. Graphs are at the center of everything in the new system. They're designed to give technical animators more creative freedom for their gameplay implementation without having to code. Graphs are approachable, yet extensible, and reduce the bottleneck on programming. They are built on a new graph stack, just like Shader Graph 2, and can be packaged and reused. You could use runtime rigging for any character type, or indeed create your own nodes with your own special source. The all-new state machine is truly hierarchical, designed to scale even if you have thousands of animation sources. It's highly optimized, much easier to read, refactor, and reused with layers, blend spaces, subgraphs, integrated rig graphs, as well as constraints and math operations as well. You'll be able to easily swap animation while keeping your orchestration logic intact. So it not only offers you a serious level of control over your animation, but incredible performance at scale as well. I love this next feature. So we're working on live visual graph debugging with in-game recording and gameplay. So this makes it easy to navigate to the source of any particular animation problem that you've got, no matter how complex the setup. You can simply record and then rewind the game data frame by frame and see what's going on in the graph at any particular moment. Not only does this mean that you're going to ship fewer in-game animation bugs, but it means you can afford to make some changes later in production because we're effectively de-risking. The new animation system is, of course, built with performance in mind. It's built on ECS and, of course, therefore works with game objects too. It's written in C# and high-performance C#, and all animation code is running burst compatible, meaning you have performance, kind of native execution. You'll have control over the execution order, customizable phases, and all callbacks will be deferred. We've also removed some of the former limitations, like, for example, the sync point bottleneck, the overhead when rebinding animations at runtime. And what you're seeing here is a demo of 1,000 nights running on this new system, all at a steady 30 FPS inside the editor. Really, this is just the beginning. So, Andrew, what hero character would be complete without a world to explore? Let's talk about world building. Unity's new world-building system is powered by entities and built with the future of game development in mind. These new tools are designed primarily for technical artists choosing this Unity to build bigger, more ambitious games. Our goal is to offer much more flexibility during iteration, later in production, and the foundational tech is there to unlock unprecedented performance at scale across all of Unity's supported platforms. Let's have a look at some highlights. Once in the editor, you can establish masks and procedural rule sets based on altitude, curvature, and slope. And that offers non-destructive editing, super important, and adaptation during your edits. Ultimately, we want to give you more flexibility throughout production when you find changes that you want to make. Really cool. And here you can see how we grab this piece of an island, duplicate it, drag it across, and it's all of those procedural rule sets just kick in and make it work perfectly. Here you can see how we integrate shader graph into the terrain surface and enable blending of meshes far more seamlessly. So this is one of those kind of long-standing feature requests, and I think it looks pretty nice. And here we have an example of how you can integrate hero assets in and have all of your rules, materials, scattered assets, and masks respond to your placement. So this basically means you can spend more time finding the perfect layout of the level without having to worry and rework everything if you change your mind. Absolutely love this thing. It's great. So for performance as well, there's virtual texturing and tessellation, and they provide more detail in the world close to the player where they can see it the most, and it automatically reduces complexity away from the camera to optimize performance. And here we can see how the system is quickly setting up procedurally scattered objects like speed trees. Remember, this is using entities under the hood. So we enable density up close and then scale in the background, which makes the best use of the capabilities of the target hardware device. And all of this equates to performance at scale for your most ambitious endeavors. And of course, it wouldn't make sense for us to release tools like this only on high-end platforms. So we want to offer you the flexibility to choose the right platforms for your creations, no matter what your ambition. Whether you're targeting mobile, PC, console, XR, we want to give you stunning graphics and performance. Let's recap power, Andrew. So we have ECS for all, built into the core of Unity, powering game objects and unlocking big performance boosts for everybody. We have new features coming built on this foundation, a new animation system, and a new world-building system. And these target flexibility, scale, and platform reach. So Andrew, lots of exciting stuff coming in development. Some of it a ways off. Back to you to wrap things up.
Thank you, Will. So coming back to the goal for our next generation, it's to ensure that you have a future-proof engine. It's been really exciting to share what we have in store for you. We want to share early, and we want your feedback. We want to make sure that we're really hitting the mark with the next generation. And a huge shout out to the engineering teams that have been working hard to bring you Unity 6 and bring you what's next and all the great updates that we've shared today. They're also all ready and eager to listen to your feedback. So that is a wrap, everybody. We started with the Unity 6 generation, and we talked about how we'll release Unity to you with our new generational model. We shared some of the highlights coming as part of that Unity 6 generation. Unity 6 is going to be available on October 17th in GA, and the first update arriving April next year. And then we gave you insight on where we're going to take Unity next. And we talked about how we're going to unify our solution, making it simpler to make the right choice, and how we're going to be relentless in returning iteration speed and productivity to your editor experience. And lastly, bringing powerful, performant tools and runtime to play. You can download the Unity 6 preview right in the hub, and come join us on Unity discussions. So we're going to be hosting dedicated threads with our teams at the ready to hear your feedback on what we shared today or in this video if you're watching it on YouTube. So thank you for all of your attention today. It's been great to share everything with you. So that's goodbye from me.
Goodbye from me. Thanks, everybody.
Thank you, everybody.